What's up, everyone? Hey guys, this is section 5.2 from our Calc 3 sequence material, sequence and series. We're talking about how you can determine the summation, or what is the result from however methods we're trying to use, which I'll elucidate here in this video for the expression that's been given. 2n plus 1 divided by the quantity n squared plus n, that quantity also is squared. First step in the hint in the text is that we need to factor out. And so I notice that when you expand and then factor, and maybe there's some issues here. For one thing, we do have crappy video. Sorry for the C word. But the point is that we're going to talk about that I factor out n squared, and then I use this idea of partial fraction decomposition. Tried a couple of various ways, but I stumbled across one. Well, this one I thought if I decompose everything, every factor gets split, that probably would work, but I don't want it to. I don't really want it to work that way. So you're going to see some clips through this problem set where we get way too many letters involved, and I say, let's go back. And so in going back, perhaps instead of trying to consider A, B, C, and D, we just break this apart by the factors we found before. One of them is 1 over, or A over n squared. And then the other one is B over n squared, or no, n plus 1 squared. Major step there. Pause and catch that all. There's not even enough time to go through it in the time that I've given you, but the steps there are true. You find a common denominator by pushing them back through, which means the numerators have to change. And then you look for ways that you can combine so that the n term and the constant term are made up of expressions involving a and b. A little bit of solving leaves that a is 1 and b is negative 1. Continuing on, we did do some research. We found out that the summation of 1 over n squared from n equals 1 to infinity, in fact, I think Euler came up with this one, is pi squared over 6. And the other one is broken up so that we are looking at 1 minus pi squared over 6. And when you combine them, you get 1 for an answer. Well, then we thought about it. We went back to this problem, right? We went back to the question, and it says it's a telescoping series. So I wonder if how you get this structure of a telescoping series to develop. Well, first of all, you should start considering the partial sums. What's the first partial sum? What do you get for an answer? Save that. Find the second partial sum and combine that with the first one. You know, the whole process of adding the next element of the sequence. It looks like there's a middle part that crosses out, leaving us with 1 minus 1 over 9. The third partial sum crosses out the middle term, leaving us with 1 minus 1 over 16, and so on, down to the arbitrary k value. It turns out that you're going to add up the k minus 1 partial sum plus the sequence element at k, and things cross out, and you're left with 1 minus 1 over quantity k plus 1 squared. That goes to 0 as k goes to infinity, and therefore 1 is the limit of that series. Thank you for watching this video. Thank you for checking it out. Make sure you watch that big old longer video on 5.3, or maybe you came there from here. Catch you later.